again. Welcome back. I haven't been updating any new video lately, so today I'm going to do integration by parts. We're going to use this recurring formula. So this is called recurring integral to solve this. Before I do that, please just remind you, if you haven't subscribed this channel, please do so you can get the latest update. Thank you for that. So let's do so we know In, which is integral, N is the integer. So we might say N is the positive greater than 1. So that means N can be starting with 1, like 1, 2, 3, until it's a natural number. N is a natural number. So it's a sequence. So we're going to prove this recurring formula. So I'm going to say In is x to the power n. Then I move this term. We're using the integration by parts. So we know the integration by parts is u dv equal to u times by v, then v du. So this is the formula we're going to use. So we're going to find a u and a v first. So I may call this as a u. So then I'm going to integrate it, ex to the position as a v. So I'll copy x to the power n, then that's my u. So integrate to e to the power x. So this is my u. So this is the u. This is the v, and that's the u. So according to the above formula, so uv is x to the power n times by e to the power v. So this this is v. So that's u and v. Then integrate v, you copy ex, e to the power x, then differentiate the x to the power n, become n times by x to the power n minus 1 dx. Then I'm going to copy this first term. Then I move n to the outside, become e to the power x, x to the power negative 1. So I'll maybe put up front. So you can see this is the recurring formulas code. So this is the I to the power in1. So you can see here is n reduced by 1. So therefore, you proved In is x to the power of n times by e to the power of x minus n times by n minus 1. So now we're going to use this formula to solve this x to the power 3 e to the power of x. So this is n is 3. So therefore, I can see this is the n3. So n equal to 3. So that means I'm going to each I3 is x. You use the formula we just developed from a recurring. This is the recurring integral. So be x to the power of 3 times by e to the power of x, and n is 3. So then times by n I2, because n minus 1 is 3 minus 1 is 2. So now I'm going to do I2. I2 is x to the power of 2, e to the power of x, minus 2 times by I1. So if I Then I'll do I1. So we just keep going Y1 because we need to find I1. I1 just x to the power 1 EX, which is easy. So I'm going to do integration by parts. So it will be x times by e to the power x minus integration e to the power x. Then to differentiate the x is 1, so it'll be dx. So that leads to ex e to the power x minus e to the power x. You might say plus c1. All right, so we put these three together. So therefore I3, which is the one I needed, is equal to, we substitute x to the power 3 times by e to the power x, 3 times by I2. So I2 is the x squared times by e to the power x minus 2 times by I1. I1 is this. So we put a square bracket and x e to the power x minus e to the power x and plus c1. All right, now we're going to expand all the brackets. So this become negative 3x squared e to the power of x. Then 3 times by negative 3 and negative 2 is positive 6. And 6 expanding to the brackets. Then you've got 6 plus c. So that's the answer. You can see x to the power 3, 2, 1. So this is a recurring. If I'm going to expanding, maybe take a common factor out. So become x3, 3x squared plus 6x plus 6. So that's the answer. Hopefully you like this solution. It's using called recurring integration, using how many times? 3 times the integration by parts, once, twice, and third time. So we solve this recurring integral using the formula. If you like the video, please give us the thumbs up, and I'll see you next video. Bye.